figure, I want to introduce you to all of them that we're going to talk about and why this is set up the way it is on your front page here. This is the family tree, I call it. The family tree of quadrilaterals. It has all the quadrilaterals we'll study. It starts right up the top with just a quadrilateral. Any four-sided figure can be called a quadrilateral, right? And the only thing you guys know about it you learned on Friday was, anybody remember the number of degrees inside? Quadrilateral four-sided figure. 180 times 4 minus 2, 360 degrees. Okay, that's all I know about it. Then we start getting more specific. Everyone see right below a quadrilateral there? That's Tony. Tony the trapezoid. Okay, so that's a trapezoid. I'll tell you why at the end, why it's on top, why he's the kingpin. And then from the trapezoid, we break off a little bit, right? We break off. We break off to the right. You got yourself Isaac here. Isaac the isosceles trapezoid. There's a word we've heard before, isosceles. So you got trapezoid to isosceles trapezoid. And then we have this group of figures right here. All right, led off by the top by the parallelogram. All of these, again, we will spend 1 to 2 days every time talking about the parallelogram. And everyone see underneath the parallelogram, you have three figures, 3 kids, however you want to call it. Anybody have an idea of any of these 3 underneath the parallelogram? You can start with Randy the rhombus here. Got the rhombus. And right across from the rhombus is Rosie, the rectangle. And then you have the golden child at the bottom, the golden child of the quadrilateral family. Maybe some of you can relate. Susie, the square. All right, why, before we move on, why is it set up like this? Why is it set up like this? As you go from the bottom up, so a square is a rectangle. A square is a parallelogram. But I cannot go in reverse and go down and say a parallelogram is a square. All right? I could say a rectangle is a parallelogram. I could take any bottom figure and say it's one of the ones above. All right, so as you read this from bottom up, not top down. So a rhombus is a trapezoid. A parallelogram is a type of trapezoid. But I can't say a trapezoid is a square. Make sense? You always read it bottom up to say which figure is which. Here's the 2 we're going to talk about today. Trapezoid, actually today and tomorrow. Trapezoid and isosceles trapezoid. All right, let's start talking. This should be a quick day. Hopefully, we'll be able to get out of here with no assignment. We'll see. Let's talk about the top of the tree. Trapezoid. This first trapezoid we're going to draw is called trapezoid ABCD. Okay, ABCD. And it's not the one below. You're going to draw yourself your own trapezoid right now. When we dealt with triangles, and I said this is triangle ABC, did anybody ever have to worry about where you placed A, B, and C on the vertices? No. Now we got to worry. Okay, you have to label every quadrilateral in a certain order. First thing I want you to do, place A on any vertice right now, that trapezoid you just made. Place A anywhere. From here now, when you label the rest of it, you have to go clockwise or counterclockwise. You cannot jump diagonally. It throws everything off. All right, you have to go clockwise or counterclockwise. So go ahead and label the rest. B, C, D. Clockwise or counterclockwise. That is how you, this is not just for a trapezoid, any quadrilateral. It's got to be labeled clockwise or counterclockwise. Let's talk property. There's only one property of a trapezoid. One pair of opposite sides are parallel. Those aren't hash marks. What do I put on there? Arrows. All right. So on AD and BC, we should have arrows. And I want to go back to unit 3 with you when we did parallel lines. Anybody remember what type of angles A and B were? What did we call it? Or C and D? Back when we did the parallel line unit, A and B had a special name and the same name for C and D. Are they inside or outside? Inside. Same side of the transversal here, B and A, or opposite? Same side of this line here or opposite? Okay, so put them together. What did we call them? Same side, interior. Were they congruent or parallel, or congruent or supplementary? There you go. So remember that, please. Because these lines are parallel, B and A add to 180, and so do C and D. All right, so keep that in mind as we do some of these problems today. B and A add to 180, and so do C and D. Hey, guys, that is it. That's the trapezoid. That's all I got for you. One pair of opposite sides are parallel. That's it. That is it. That's all I got for you. You ready to go to the souped up version, version 2.0? The isosceles trapezoid. This will be isosceles trapezoid EFGH. EFGH, so go ahead and appropriately label that one for me. Doesn't matter if it matches mine or not. Still a trapezoid. So what markings can you automatically put on there? It's a trapezoid, remember. Now I'm just putting the word isosceles in front of it. It's still a trapezoid. So we should have one pair of opposite sides parallel still. With some extra properties now because it's isosceles. All right. That term right there we talked about in triangles. Where did it come up in triangles? Where did it come up in triangles? I got to call my first number here of the day. Here we go. We talked about isosceles triangles. Where did that number come up? Where did that term come up? Here we go. Talk to me. When we talked isosceles triangles back in the day, Halo, how'd that involve? Or what did that involve? If a triangle was isosceles. Two equal sides. Same thing here. All right. It's the non-parallel sides. Everyone see the two sides that aren't parallel? Here we go. Looks like I got to break this out for the first time. There we go. We don't want anybody napping here. Come on now. Yep. How annoying can he get? Pretty annoying. We're not going to doze off in this class anymore. Those are the two sides that are congruent. Everybody good? Okay. I don't want to call it the non-parallel sides anymore. They have a name, and those are called the legs. The legs of an isosceles trapezoid are congruent, and that's your first property down below. In an isosceles trapezoid, legs are congruent. Those are the non-parallel sides. I think you knew something else about an isosceles triangle. Yes, the two sides were equal. What else did you remember from an isosceles triangle? Let's go. Jesse? Yeah, two angles. Same thing here. A little bit more though. They're congruent. And ready for this one? Not only those two, the top two. And those are called, the second property, base angles. The base angles are congruent in an isosceles trapezoid. So the legs are congruent, and so are the base angles. And there's one more property. Probably won't get this one just by the name of it. Don't draw this in, please. Remind me from Friday, you guys that were here, what's that called that I just drew in there? connects two non-consecutive vertices. If you were here on Friday, that's called a what? Let's go here. Where am I going with that one? Lennon, what did I call that? Connects two non-consecutive vertices, corner to corner here. You've heard of it before. Were you here on Friday? Yeah. Okay. Yeah, diagonal, right, everyone? This is a diagonal. Don't overthink this. That's a diagonal. And when you draw both in for an isosceles trapezoid, the diagonals are congruent. Okay, so just remember, when you connect those non-consecutive vertices, those two diagonals are congruent. I want to make this clear. These are only for an isosceles trapezoid. Trapezoid, one pair of parallel sides, that's it. These are only for an isosceles trapezoid. It has to be isosceles. All right, we're going to use them in the algebra questions, and then we're going to use them in a proof. Let's do it. These are both isosceles trapezoids. Just find the value of the variables. How are you going to solve for x in the first one? What equation do you want to set up to solve for x? I put 3 up there to mess with your mind because you only need 2 in the equation. Remember, isosceles trapezoid, legs are congruent. Legs are congruent. Where are we going to go with this first equation? Juliana, what do you want me to set up?
3x minus 3 equals x plus 1.
Yeah, I don't need the x plus x minus 1. Legs are equal. Legs are congruent in an isosceles trapezoid. Nice, easy one to get you guys started. We got 2x equals 8. X equals 4. All right, not bad. Any questions there? Nice, easy one before we get a little bit more hardcore. All right, let's talk 2 now. Now we're talking about the angles. First off, right off the bat, we just learned, hey, base angles are equal, but is that going to make any sense setting y equal to 6x plus 20? Probably don't want to touch that. Probably don't want to touch that at all. All right, so let's go back to the original diagram. I do have 2 angles, though, that have x in it. So I need your help. What do you know about those 2 angles? We talked at the beginning. Remember, these lines are parallel. These are a certain type of angles, which makes them blank. So I can set up this equation. All right, what do I know about those 2 angles if those lines are parallel? What did we say? What did we say? Alex, what did we say? And they are congruent or supplementary. There we go. I got my equation. 6x plus 20 plus the 4x angle adds to 180. Same side interior. Perfect. I'll wait till you guys finish this so I can ask somebody what you got for x. All right. When you have x, let me know if you don't. Take your time if you don't. Maddie, what do you have? 16. Good work. All right, so we got 16. We still got a y, though, to solve for. Think about the properties. How would you get y now? Explain to me how you would get y. Remember your properties. How are you going to get? Remember, you already have the value of x. So how can I use that value and a isosceles trapezoid property to get y? Go explain your thinking for me. Explain your thinking, Hayden.
The base angles are.
Yes, they are. So these are equal, and we already know the value of x. So what can I do with that 16?
16 equals y.
16 equals y?
So plug it into the.
There you go. Plug it. Where do you want me to plug it in? Yep. So everyone, hey, y is equal to 6 times now, plug it in, 16 plus 20. Base angles are equal. When you have that value, Hayden, let me know. There we go. So legs were congruent in number 1. Same side interior supplementary, base angles congruent. All good before we get to the tough one. All right, let's get to this tough one. Let's see if we can what we can do here before we hit up the proof. All right. Find x. Well, I want to name x first. That everyone see that line segment we got to try to find the length of? You actually know what it's called, but you're just so used to seeing it in a triangle. What did we call that segment that started at a vertice and perpendicular to the opposite side in a triangle? That was called an altitude. This is an altitude too. All right, just not in the triangle. Starts from a vertice, perpendicular to the opposite side. Looks like it's an isosceles trapezoid. If that's 13, we can at least label 13 over there. Where are we going to go with this? Let me give you a hint to get started. Draw in the other altitude on the other side. So coming from the other vertice here, draw in the other altitude for me. Everyone see the 2 triangles now formed in the diagram. Everyone has a pair of congruent sides, right? The 13s. Everyone has a pair of right angles. Also, this is an isosceles trapezoid. What do you know about these 2 base angles? They are congruent because in an isosceles, where am I going with this? All right. I have 2 pairs of angles and a pair of sides. What do you know about those triangles? I have 2 pairs of angles and a side. What do you know about the triangles? They're congruent. Angle, angle, side. Why am I going all this way for you? If the triangles are congruent, CPCTC says, everybody, aren't these 2 pieces equal now too? If the triangles are congruent, so are those pieces. And watch how we're going to find those pieces. Hey, 24 up here. Going to have a 24 down there. And the whole thing was 34, but we already proved these 2 pieces are equal. I'll call on somebody here in a second. What is the length of each of those pieces then? I had 34 total for the whole side length. This piece already has taken up 24, and these are congruent. So what are those pieces going to be then? What's the length of those pieces? If we can get there. Hi, Ryan. What do you got?
5.
5, because I had 10 left over for 2 congruent parts. Nice work. I don't know if anybody sees where we're going, but we have used this method multiple times. In a right triangle, if I have 2 sides, how can you find the third? Pythagorean theorem. A squared plus B squared equals C squared. There you go. That's how this is getting done. Go through each side with me. What's the 5? A leg or hypotenuse? 5. Leg or hypotenuse? Leg. It's got to go in for A or B. Yep, 5 squared. How about the X, the side we're finding, the altitude? Leg or hypotenuse? Leg. So that's got to go in for the other, either A or B. And then 13 is your hypotenuse for C. All right, go ahead and solve. Remember at the end, to get rid of the squared on x, you got to take the square root of both sides. All right, when you have it, let me know. Juliana, what do you got when you have it? What'd you get for 5 squared? 25?
Yeah.
And then 169 for 13 squared?
Yeah.
You move the 25 over how?
Oh, wait. I put 162 in my calculator.
All right. That's probably why. Go ahead. Regroup.
12.
There we go. That looks better. 12. Any issues? We still know those properties of an isosceles trapezoid because we're going to need to use them here. Every figure comes with proofs. Every one of these quadrilaterals comes with proofs. I know that's not a great thing for some of you, but hey, we got to grind through it then. We got this as an isosceles trapezoid, AD, congruent to BC. All right. And can everyone locate those angles I'm trying to prove congruent? And you don't mark them, right? Just find them, the angles I'm asking you to prove congruent. Can we all agree those are not the base angles, correct? That I'm asking you to prove. They're part of them, but they're not the actual base angles. So this is not going to be a two-step proof. All right. I'm hoping this is like repetitive, especially with me saying it all the time. Those angles aren't going to be congruent unless what's congruent first? The triangles that contain them. So I need somebody in here to name a pair of triangles that contain DBA and CAB so we can get them congruent. I need a pair of triangles congruent before those angles are congruent. So find a pair of triangles right now that contain DBA and CAB. And the name is in the angles already. And I will highlight them up here on the board. Name me a pair here. Name me a pair. Well, almost had it. Almost went wrong there. I'll get it. Hold on. Nope, not here. Oh, there we go. Rowan, what do you got, big dog?
DAB and CBA.
Yeah, yep, DAB, this triangle right here. Get it congruent to CAB. All right, let's get them congruent. We got 5 methods. We already have a pair of sides down, right? We already have a pair of sides. When I call on somebody next here, you can use anything we've used in the past, or hey, you have properties of an isosceles trapezoid now that you could possibly use. Because we were told this is an isosceles trapezoid, so you got a couple properties. But I'll take anything right now. Any sides or angles you know are congruent in those 2 overlapping triangles. Anything here for me. Lennon, back to you there. What do you got? Those 2 overlapping, any angles or sides that you can tell me are congruent? You got properties of an isosceles trapezoid we've been working with today. You've got some things we've used in the past, possibly.
DAB and CBA.
The angles? Why? Go ahead. Yeah, you're right. Just tell me why. Why those 2? DAB and CBA, these ones right here. Why? It's correct. What type of figure is this? And what's one of the main properties of an isosceles trapezoid that you're giving me right now? Look back at your properties. Look back. There's 3 of them. There's 3 of them, and you just gave me one. Base angles are congruent. That's what we're using. All right, so let's write it in now. Angle DAB is congruent to angle CBA. All right, how am I going to have you write this? Tell me what the figure is. So, and you can abbreviate it, ISOS. If you want to abbreviate trapezoid, TRAP, I'll let you do it. I won't fight it. So I was given it was an isosceles trapezoid. Remember our arrow days? Implies. Then tell me the property you just used. What, Lennon, back to you. What property did we just use? All right, so tell me base angles are congruent. So tell me the figure and the property being used. All right, we got a pair of angles down. Got it? Looking for at least one more something, right? And those 2 overlapping triangles. Anything here you want to go with? Anything, Maddie, you want to go with? Great job. AB equals AB. That is something we've used in the past called what, Maddie? There you go. That's reflexive. And that gives me a pair of sides. So it looks like if I look at one of the triangles only, looks like I'm good to go. So let's write a congruent statement. Triangle DAB congruent to CBA. You let me know what method. Remember, we had 5 of them. Which one is being used here based on what's been given to me? Where am I going? Keating?
Side angle side.
Side angle side. I want to stop here in case anybody was thinking, if I called on you, was anybody going to give me maybe CA congruent to DB because diagonals are congruent? That is true, but hey, be careful. I can't use that with, I would have to go all 3 sides and say side, side, side. Because if you did that, take a look. Let me draw out DAB. You would have had DA, the angle, and here. Is that angle in between? No, right? So I'm just saying, if you guys wanted the diagonals congruent, you would have needed to do reflexive, diagonals congruent, and do side, side, side. Okay, so if you said diagonals were congruent, it would have to be by side, 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 because the angle wouldn't have been in between. All right, and then finally, now that the triangles are congruent, so are those angles. DBA congruent to CAB. And what do we always talk about here? If the triangles are congruent, the angles are sides, Will, because of Taylor. Finish this. CPCTC. Okay. So use your properties tonight when you come to the isosceles trapezoid question. All right. Hopefully you guys can get out of here without any work. You are not done until you check your answers, remember. You are not done until you check your answers. If you get stuck on the proof, call me over.